Hello everyone, welcome to my YouTube channel Tech with Ankush again. So today is a theory class and today I will discuss like what is Azure Application Gateway, like what does Azure Application Gateway includes and its features. Then I will cover how Azure Application Gateway works, like it has front-end IP listeners, routing rules, then how load balancing works in Application Gateway. What does Web Application Firewall do in Application Gateway, then backend pools, then Application Gateway routing, like how routing works in Gateway, like it has two types of routing, path-based and multi-site. Then TLS SSL termination, what does it mean and how it works in this Application Gateway, Help Probe, auto scaling, WebSocket. So let me start with like what is Azure Application Gateway first. And please, if you like my video, please like the video. If you have any queries, please type it in the comment and also subscribe my channel. So let us start now. So what is Azure Application Gateway? Azure Application Gateway is a cloud service that acts like a smart traffic manager and security guard for web applications. Instead of sending user requests directly to web servers, traffic flows through the application gateway, which then decides how to handle and route it. Means application gateway, we can say it is also a load balancer, and but it's a smart load balancer, and it has more features as compared to simple load balancer. And where web apps can be hosted, like where it will send the traffic. So web application can be hosted on, let me, like it will have hosted on Azure virtual machines, Azure virtual machines scale sets like VMSS, app service, then on-premises servers in our data center. So it means like it will provide the flexibility to make it useful for hybrid environments, like it contains mix of both, like cloud or on premises, or we can keep individual also, like only cloud, or we can keep on premises or both. So now come let us come to the second slide. So now key functions of Azure Application Gateway. So first is load balancing with health monitoring. Like it will distribute incoming traffic across multiple servers using round robin method. Round robin method means like if there is server 1, server 2, server 3, and if we have like 6 requests, 1, 2, 3, 4, 5, 6, I can say requests. So first request will go for server 1, then second will go to server 2, then it will go to server 3. And same, fourth will go to server 1, then server 2, then server 3. So this is known as round robin method. Also, it will continuously check server health. If a server goes down, the traffic will stop going there. Like in case if this server is not working, like one is not working, then it will transfer this request to server 2 and this one to server 3, so that no request will get dropped. Now comes the TLS termination, encryption handling. Like it, this application gateway, it also have the TLS termination feature. Means like it will encrypt the data. Like if a user sends the data to a server, like if this request is going to a server, first it will come to a load balance. This application gateway. Uh, Let me just make the things clear. So like so there is an application gateway. So if user is sending a request, it will go here and it will come like in an encrypted form because it works on layer 7. Then the request will also go to this server and it is also go in a encrypted form. So it means like this. Like a user sends a request to a gateway in encrypted form, then gateway decrypts the request, then also and check what does request contain, and then it will send the request to the server, and again it will send in a encrypted form. So actually, this task will be performed by these servers, but gateway does this task, so it will save the power for the servers. So we can say it means like servers only focus on running the web apps instead of wasting power on encryption. So server don't do this job, only this application gateway it perform this job. So we can see normally server spends a lot of power encrypting decrypting traffic. Application gateway can take over this job, and the server to main focus only on running web apps instead of wasting power on encryption, supports end to end. So this job has been done by application gateway. Now session affinity, or we can say stickiness. So it means like if there is a user one and he has connected with like he's doing shopping on he's connected with server one and he's doing shopping on the website, and if there is something present on his cart, and if sometimes the session will drop this and if the user again send the request to the server, it will go to this server only, or the session will remain for some period of time. So it means like the all the user which he has selected the product, it will keep remain on his cart so that it will help in the production. So this is known as session affinity or stickiness. Now comes the web application firewall. So web application firewall means this server, it also like not server, this application gateway, it also provide protection against common attacks such as SQL injection, cross-site scripting. So it also act as a security filter and only allow only the safe traffic. Then it support these type of protocol like HTTP, HTTPS, HTTP by 2. This is the advanced. I will discuss later on. Then WebSockets. I will also discuss this later on. So it is suitable for modern apps. Then auto scaling, like if the traffic increases, the gateway automatically scale up to handle more requests, and if the traffic drops, it also scale down to save costs. Then connection draining, like if there is a request from server to this application gateway, like I have to do update and I'm going for maintenance, so I will be turn off. So what does this application do? It will ask the server to first finish the ongoing request or ongoing services, and then you can stop it. So it avoids the breaking user sessions. So now come the topic like how Azure Application Gateway works. Okay. So Azure Application Gateway is a service that help manage, secure, and balance web traffic across web servers, like a smart traffic manager for website and applications. It has several important parts that works together to make sure requests from users go to the right servers safely and efficiently. So I already explained you, like it works as a smart traffic manager, and it transfer the secure request from users to the appropriate servers. So these are the components which make the server to work properly. So first contains this front end IP address. So this is the entry point for all user requests. Like when someone opens our website or app, their request first reaches this front end IP address. It can be public or private. So it means like if when a user get connected to a server, let me explain you in detail. Just a second. So like if there is a user and it sends the like it wants to access a website which is on the like server. So first this request will go to application gateway. So and how do user connect with the application gateway and the server? Like it is connected by front end IP. So front end IP can be public or private. So public if like our app is or our app application or servers, they are uh, available on the internet, or we can say our gateway is available on the internet, then the front end IP will be public. And is if our app is internal, like it's under the company network, then it is private. So we can have one public IP and one private IP per application gateway, not more than that. Then comes listeners. A listener is what actually listens for incoming web request on the front end IP. So listener means like these are the, I can say, like protocols, or I can say these are the yeah, these we can say these are the things which listen the request when it comes to the front end IP. Like if like there are 10 requests, so all the request the listener will listen all the request on the front end IP. It listens on a specific combination of like it works on these it uses this protocol like HTTP, HTTPS. Then it also detects the port. Then it will check the host name or IP address. And there are two type of listener: basic and multi-site. Like if routes traffic based only on path, like there is www.google.com dash images, then or dash videos. Like if it only uses the path, then that is a basic listener. And if like there is a request like www.google.com and there is one more request www.facebook.com, then it is a multi-site listener. So let me explain you detail. Like if there is a request like www, or let me just use this thing. Like if there is a request like www.google.com images, or there is a request like www.google.com/video. So if here only the basic listener it is required, because currently it is only using the path. Like like if we have two servers, one is image and one is this is a image server and this is a video server. So what does this listener will do? If this is a request, then it will transfer this request to this application gateway will transfer the request to image server. If there is a request for video, it will send the request to video server. So it's a basic listener. And there is then it comes the multi-site listeners. So now like if there is like if there are like if there is a request www.google.com and so now, if like there is a like if we are using multi-site listener, and we get the request, like we get like two requests, like google.com and facebook.com request together. So these are, like, I can say it based on both, like hostname plus path. Okay, so if there is google.com/images, or here videos, or I can say images, any request. So it currently, this multi-site listener, it is using the hostname. This is the hostname, plus it also using the path. So there is a image and there is video. So first request will go to this Facebook image server, and the video will go to here. And same, if this is a request for image for Google, it will send the request to here. And if there is one more request which is for video, it will send to here. So in basic listener, it only follows the path, but in multi-site listener, it uses both hostname plus path. And listener also manage SSL and TLS certificates. Like it is used for secure communication gateway with it is used with secure communication between user and application gateway. Now this gateway also uses this routing rules. Like we can say routing rules are the rules, or we can say brain, that application gateway follows, like where it will send the request. Like if the list like it connects the listener, like to the backend pool, and it decides how to interpret the URL, like hostname and path, or just hostname, so that it will send the traffic to the correct servers. And it use all these rules, like it uses the protocol, then session stickiness, connection training, health probes, request timeout period. So I have explained all these things previously. So now comes load balancing and application gateway. So I have already explained you before. It works on the 7th layer of the OSI model, and other than this, like the load balancer, it works on Azure load balancer, it works on layer 4. But this application gateway load balancer, or we can say application gateway, it works on layer 7. And it uses the round robin method, like one request will go for one, then second, then third, then fourth will again go to one, then second, then third, like if we have 3 servers. And we can also configure the session stickiness. So now comes the web application firewall. So web application firewall. A web application firewall is like a security guard for your website or web app. It stands in front of your application and checks every request that comes from users before it reaches your server. Its main job is to protect your website from hackers and malicious traffic automatically. Where does it fits in application gateway? Their request first reaches the WAF. The WAF checks if the request looks safe. Only safe requests are passed on to the listener, and then to your backend servers. If something looks suspicious, like a hacking attempt, the WA blocks it. So the web application firewall, we can say it's like a security provided by application gateway. If there is the malicious, or we can say hacker attempt made by the user, it blocks the like hacker and malicious traffic, and only the safe traffic it sends to our server. So let me explain it. How does it work? Like uh, let me use brown color. So let me explain you. Like this is our application gateway. So and it has front end IP. Then it contains this knife. Then this web application firewall, or I can say web WAF in short form. So first of all, like if someone try to access the website and if we are using application gateway, so first of all the request will in application gateway it goes here like first the request will go here from the user, then this request then it the application gateway send this request to WAF like web application firewall. If like there are like I can say three requests and these two are bad one. So now what does this web application firewall will do? It will blow like all three requests will go from front end IP to here, and it will block these uh, bad requests. I can say these are bad requests, so it will block here in the web application gateway, and only the safe request it will go to the listener. So this is the way how this web application firewall will work. Like first the request reaches the WAF, then if it checks it's good or not, then it will send the request to listener. And if something is suspicious, it will block it. So now this web application firewall, it like what kind of threats it will block, like it will uh, block these threats like SQL injections, like hacker tries to send malicious database commands through a website form, then cross site scripting, hacker injects harmful scripts into a website that runs in a user browser, then injection, like hacker tries to run system commands on our server, then HTTP request smuggling response splitting tricks the web server into misreading or split web requests, remote file inclusion, like tries to load a harmful file from another location, both crawlers and scanners like automated tools or bots that overload or scan our website for weakness, then protocol violations, requests that don't follow normal web standards, often a sign of attack. So WAF detect all these uh, threats and malicious traffic and block these threats and malicious traffic, and only safe request will go to our server, so our servers will remain safe. So how WF knows like what to block? Like the WF, like it uses a set of security rules created by experts from a community called AWASP, Open Web Application Security Project. Like OWASP provides a list of common and dangerous web attacks. These rules are called in a core rule set. So WASP, like it's a, like we can say it's a community that that detects all these attacks, and these creates the rules, and the rules are collected in the uh, core rule set. So we can say it's WOWASP. It's like a community. It detects all the attacks from hackers, malicious traffic, bots, crawlers, and then they will provide the security, and they will provide the rules one by one. So these are the rules, or we can say Azure WF supports 4 versions of these rules like CRS 3.2, 3.1, 3.0 to CRS 2.2.9. All these rules are created by this OWASP. Then web customize options. So yeah, so we can customize how WF behaves, like select specific rules, only check for certain type of threads, specify which part of the request to inspect, like only check URL and header, not the body, limit message size, prevent huge uploads that could overload our servers. Means regarding the WAF security rules, we have the options, like we can only select specific rules, like we can select this one 3.1 or this one, or we can select all, or we can select like which part of the request to inspect, like it will only check the URL like www or headers, not the body, head, like www, like the URL dot google.com, or the like what does it contain inside the body of that request, or just the headers, like what does it this request is using. Then limit file size, like it also block, like if a user trying to upload a big file, so we can also use limit the size, like user can only upload like only like 5 MB, not more than 5 MB. So we can use these settings on our WA. So after WA, Web Application Firewall, it comes the backend pools. So let me explain backend pool in detail. So backend pool, we can say these are the like servers or apps which are to which this application gateway sends the request, and it can be a virtual machine only, or so it can be use this. Yeah, so it can be only what we can use virtual machines or virtual machine scale sets. It's the feature in Azure. And Azure, we can use Azure App Service or on-premises servers. So backend pool is flexible. It can mix cloud or on-premises servers, or we can use app service. So how we can send the traffic to these backend pools? Like I already explained you, the application gateway, it contains the load balancer feature. So it distribute traffic across all the servers using round robin method. Then so that no server will get uploaded. Plus, it also uses the health pro feature, like only the healthy servers gets the traffic. And like during setup of these servers, we provide the IP address or DNS name for of each server, and also ensure like all servers configured the same way, like their security software ports should be same for all the servers, so the traffic behave consistently. So now using TLS SSL with backend spool. So like if our communication between this Azure Application Gateway and backend server is secure like HTTPS, then some extra configuration is needed. Like case one, like if we are using own VMs and servers, so in this case, we have to install a certificate on the backend servers. The application gateway uses an HTTP settings, and that include the certificates details. Means like for the like secure communication, we install the certificate, and also the application gateway uses the HTTP settings that includes the certificate details, the certificate which we have installed on these backend servers. The application gateway also have the details, so that uh, whenever the message sent to the server can able to read that message. So this allows the gateway to authenticate our backend servers and encrypt traffic again before sending it. So this is called re-encryption. I already explained you, like traffic is encrypted from client to gateway. Like first, encrypted traffic comes from users to application gateway, and then application gateway decrypt it. Then application gateway again uh, encrypt the traffic and send to the backend. And backend server also have the certificates, so it will know like what does this traffic like who sent this traffic. Like if we are using Azure App Service, so here no certificate setup is manually needed. Azure automatically encrypt traffic between the application gateway and the app service. The gateway automatically trusts these connection because Azure manages both. So if we are instead of our VMs or VMSS virtual machine scale set or internal on-premises servers, if we are using Azure App Service, so here no certificate setup is required, because here Azure automatically encrypt the traffic between application gateway and app service, because this is managed by Azure. So no certificate is needed. So this is more secure, more easier and secure because and Azure handles all encryption certificates and encryption. So we don't need to do any manual thing. Like if we are using VMSS virtual machines or on-premises servers, then we have to install the certificate on our servers. Plus, we have to install the HTTP settings on the gateway. This application gateway, and if we are using Azure App Service, then nothing is required. Everything will be managed by these Azure. Now comes the application gateway routing. So, application gateway, like Azure Application Gateway, like let us assume Azure Application Gateway as a traffic manager for web request. When someone visit our website, their request first comes to the gateway. The gateway then decide which server in the backend pool should handle that request based on rules which we have set. These rules define how to send the incoming traffic. Actually, the application gateway it uses two main types. One is path-based routing, then is multiple site routing. So path-based routing, like path-based routing means the gateway looks at the URL only of the request to decide where to send the traffic. So I had already explained to you, like there are, like let us say, like there are two servers, one, two, and this is a image, and this is a video. This is a application gateway. So like so here, like in path-based routing, like if someone go to www.example.com like video, then this path-based routing it will so it will check this path only. Like it is asking for video. Rest is anything. So this is the path. So this like this is the video request path is coming to the application gateway. So it will only send this path request to video only. And same if the image this request is coming, then to the application gateway. So it will send it to image server. So this is a path-based routing. So now the second is multi site routing. So like let me explain you like also. And there is a application gateway. I am just using the short name application gateway. So now like if a request is coming for like in multiple site routing, like it uses both like the path plus domain or path. So it has like everything, like it has both. So in multi-site routing, one application gateway can handle multiple websites or domains. So it means if user if a request is coming for Contoso and this Fabricum, this application gateway or listener, it will know like this request is it will send this request for application gateway, like this request is needs to be sent to Fabricum, and for Contoso it has to be sent to Contoso. So in multi-site routing, it uses both. It uses path plus domain. So here each website domain has its own DNS name, like Contoso Fabricum. So it uses the domain plus it can also use the IP address. The DNS name point to the same gateway IP address. So here the listen So the listener, it request for it listen for request to each domain, and each listener follow its own routing rule to send traffic to the same correct server. So the listener listens the request, and it will check well, like this is the request for this Fabricum website, so it will send the request to Fabricum. If this is the request for Contoso, then it will send the request to Contoso. So this is the way, like this multi-site routing also handles by application gateway. So now comes the TLS SSL termination. I have already explained you before. So let me explain the thing again so that there will be a clear picture for you. So in TLS SSL termination, when we visit a website like www.myshop.com, our browser encrypts all the data before it's sending it. Someone has to decrypt that data so the web server can read it. That decryption process is called SSL termination. It's where the encryption ends. So in Azure Application Gateway, instead our web servers do this heavy work, the gateway itself does it. That called TLS SSL termination at the gateway. Like if we want like to make the encryption all the way, the application gateway supports that. Like the gateway decrypts the request using its private key, then it re-encrypts it before sending it to backend server. So the data is secure both outside and inside our system. So let me explain. This is application gateway, and I'm just making a simple picture so it will be easy for you to understand. And these are like backend servers, or we can say backend. These are like users. So if a user if a user is send request to our application gateway, then it comes in an encrypted form. The application gateway use its private key to decrypt the traffic. Then it knows, then it checks like what does it traffic contains, whether it's good or bad using WAF. Then everything will first EG check it. Then it will send to listener inside the application gateway. Then the listener will send the request to backend server. And it also, if we have configured TLS SSL uh, on the application gateway, then it will also then it will again encrypt the traffic. I had already explained you before, and then it will send it to server, and the server will get the request. And same, it will happen in this way also. Like the server send the encrypted traffic as AG application gateway, it will decrypt, and then again it sends the encrypted traffic to the user. So this way the data is secure both outside and inside our system. Now comes the health probe. Like if like this application gateway, if we configure the health probe, then the application gateway will check if the status of the machine is good, then it will only send the traffic. If the status is not good, then it will not send the traffic. And application gateway, or if we do not configure this health probes setting, then application gateway creates a default probe like that wait for 30 seconds before deciding the server is unavailable. So means like if the application didn't get the response from the server till 30 seconds, then it thinks that the server is in good state. Auto scaling, I already explained, it will like scale up for more traffic and scale down for less traffic to save cost. Then it can also use this WebSocket and HTTP by 2 traffic. Like so, application gateway provides native support for WebSocket and HTTP 2 protocols. So these let me explain you what does these socket you why these sockets why these protocols are useful. So this application gateway, it can also use WebSocket and HTTP by two protocol. And these protocols, we can say these are faster. Like if we use the HTTP here, what will happen? Like if like here, if we are using this protocol, so if a user send the request to server, so here the request will go here, then the server will send the request, and again it will send the request again, then it will send here. So it works in like this way. But if we use WebSocket, uh, here what does happen? Like there is this is a user and this is a server. So here a connection will make. First the connection will make, like we can say, like the phone, like if we call to our friend, so it works like a call. Or if we make a phone call to our friend, so here a connection will be, if the user send the request, same time it respond, so it will work in this way, like bi-directional. And the second and the updated version for this HTTP is HTTP by 2, and this is HTTP, we can say 1.1. So this HTTP is known as HTTP 1.1, and HTTP by 2 means like here it is like more advanced. They're like this is a server, then this is user. So here the communication is faster. Plus here the upload file or the file size is small, but here we can send the larger file. So this is the difference. So if we go through it, Application Gateway provides native support for WebSocket HTTP by 2 protocol. The WebSocket HTTP protects full duplex communication between a server and a client over a long transmission control protocol. So I already explained you, like it works like a telephone call. Like the connection is full duplex. Like one will send the request, the other response, the other send the request, the first one will respond. And these protocols and over like so this HTTP, like these HTTP by two protocol by 2 protocol, these protocols have like more yeah, we can say reliability. Plus it's these are this HTTP2 is more we can say advanced as compared to this web HTTP protocol. So when to use application gateway, like I have already explained you, like if we want if we want the features like session affinity, TLS, then web application firewall, and so in this, so and if we want more security, like it works on layer 7, then we use this application gateway. So that's all today from my end. This is the theory part for the Azure Application Gateway. And in the next video, I will cover the lab part for the Azure Application Gateway. And thanks for watching. Please subscribe my channel. And if you have any query, any issues, you can comment on the video part. Thank you and have a nice day.